All right, here's our video on electron affinity and reactivity, the difference between those two. And also we'll talk about some other terms, electronegativity and electropositivity. So let's go right away. Let's get our pen ready, right? We'll try black today. So reactivity, let's talk about reactivity. I have a little arrow going here. So it's just a basic definition, the ability to do what? To combine with other elements. To combine with other elements. That's all it is. And the most reactive element is fluorine. You know fluorine's in our water, it's in toothpaste. So let's talk more about that. And by the way, we're talking about reactivity, not radioactive. Right? Radioactive gives off radiation like uranium, plutonium, and so forth. No, we're talking about reactive, just combining with other elements. All right, let's get a clear page here. All right, and here's our periodic table. And make sure we have our pen. And let's switch to red. So right over here, here's fluorine, the most reactive. And of course, they're part of the halogens, the halogen family over here. And the other reactives are over here, right over here. Store a line over here, not including hydrogen. But these are the alkali. So I'll put a little arrow pointing. Alkali metals, right? We have lithium and sodium and potassium and so on. So they're very reactive too, and so are the halogens. So the halogen family and the alkali family are very reactive. And over here, these are the nobles. These are the noble gases. And the noble gases are inert. They're non-reactive. And there's some special cases with krypton, and we'll talk about in a minute. So they're non-reactive. They're noble. And they get that word from a German scientist. His name was Hugo Erdmann. In 1898, he coined that term because he saw that they don't want to react. So, in a way, he's saying that it was undignified for them to associate with these common elements in a way, right? That's why they're noble. And these reactive elements, right, the halogens and the alkalis, and all other elements, they want to be noble, right? They want to, even though we're just personifying that, but we'll talk about that in this video also. So again, we have the nobles of helium and neon, and you're very familiar with those two, and argon and krypton and so forth. So remember, they are inert, the noble gases, but the other ones, they do react. And that reaction, we'll just change the pen, use blue, has to do something with the Octet Rule, which you should be familiar with, the Octet Rule. And it has to deal with the S and P suborbitals, I'll go over that in a minute. And we'll see why fluorine is so reactive. And here's fluorine. And I was talking about those orbitals, remember? So it has two shells, right? We can say it has two shells, or rings, or energy levels. Let's use that color. So you can see here it has a L. Oops, that's K, sorry. We have the K, and then the L energy levels. And if we had other rings, let's say we had another ring, it would just follow the letters M and N and so forth. So, and we know the energy gets higher as we go up. So you see here this S. This is a S energy level, S subshell. We call that a subshell or an orbital. And the S subshell, there can only be two in the S subshell. And you can see in fluorine it has two. And there can only be two in the first level, in the first ring. So, we want to call them a ring just for purposes here, or orbits, even though they don't orbit. Or, some people say shells. And now we have the subshell, right? Shells. Clouds, we get the word clouds, or energy levels, whatever you want to call these. Just for teaching purposes now. So, again, in the K level, you can only have S's. And the max you can have is 2, which fluorine has. In the second, the L, you can have S plus P. So the most you can have for S is 2 always. And P would be 6. So that would be a total of 8. That's the max again. And I don't want to get too deep into this. I have other videos on this if you want to go see them. But if you notice here, fluorine, it has its 2. Remember, there's always 2 S's. S subshells. So there's 2 here, and the most P's it could have in the P orbitals, it can only have 6. Right now it has what? It has 1, 2, 3, 4, 5. So fluorine wants 1 more to complete its set. And when it completes it, that's what the octet rule it means. See, the total would be 8. The total would be 8. So let's make sure. Yeah, let's change it to red. So fluorine wants 1 more because it wants to be noble. We personify it, right? Wants 1 more electron. And so we're going to come up with another term now. Well, we're not coming up with it. It's the term called electronegative. Electronegative. And fluorine is the most electronegative element. It's the most electronegative element. So I'll explain that. So if it does get another, we'll use green. If it does get another electron, an electron comes to the party. Here it is. Now it'll become an ion. It'll be a negative ion. That's where we get that electronegative from. And I'll talk about sodium in a minute, which is electropositive. So let's talk more about electronegative. All right, let's clear this out. So again, like I said before, fluorine is the most reactive. Fluorine, F, which you know is a gas. Let's not put that G there. We have to say gas. The gas. And you would see it with that, in parentheses, with that G. So it is a halogen. And I'll go back to the table in a minute. So it's the most reactive, and it is the most electronegative. So electronegativity means the ability to form bonds. So I'll put a little area there, change the color. The ability, sounds like reaction, right? The ability to form bonds. Fluorine will form a lot of bonds. There's sodium fluoride in toothpaste, members. Calcium fluoride, hydrogen fluoride, fluorine will react. And it even will react with a noble. Remember I was talking about those noble gases like krypton. It will react with krypton at cold temperatures. We'll talk about that too. So the ability to form bonds, and we'll also say the ability to gain an electron. The ability to gain an electron. Now it's very important to know, just because you're the most electronegative doesn't necessarily mean you're the most reactive. In this case, it is. You are the most reactive and the most electronegative. But you could be electropositive and be reactive also, because the alkalis are electropositive. And that's the ability to lose or donate. So again, just because you have a high electronegative rating doesn't mean you're more reactive. In the case of fluorine, it is true. And I'll use purple to show you the rating of fluorine. So fluorine, halogen gas, has an electronegativity of 3.98. Now just below fluorine is chlorine. We use that with sodium to make table salt. It has 3.16 right below it. And I'll show you the table in a minute. And to the left, we have oxygen. Oxygen's very reactive too. It's 3.44. So let's look at the table for a minute. All right, here's our electronegativity values. And make sure the pen's around. Why don't we use, we'll use green. So here's fluorine, right? Like I said before, it's the most electronegative. It's also the most reactive. I told you about oxygen. To the left of it, look at 3.44, and it just went right through it. Even nitrogen, look at that. Chlorine down here. So these are very reactive. But just because, again, you have a high electronegativity, it doesn't mean that you may be more reactive than the alkalis down here. The alkalis have a low electronegativity, but they're very reactive because they have a high electropositivity. So both could mean reactions. And of course, the most reactive of the alkalis is this one, francium, over here, but francium is very radioactive also. So as you go down in the alkalis, you become more more reactive. And as you go up, and when we're not talking about the nobles, but as you go up with the halogens over here, these are the halogens, you get more reactive. So again, you get more reactive as you go up with the halogens, more reactive as you go down with the alkalis. So again, these alkali, except for hydrogen, just hanging out there, it's not part of it. The alkali and the halogens are the most reactive families. And the halogens are electronegative, where the alkalis are electropositive. So again, they're both reactive. And it's hard to compare them as far as how this reaction works. In general, try to remember this. The halogens react better with metals. So let me use purple. I'll write it over here. The halogens react better with metals, especially the alkalis. They'll react with the alkalis, right? They're trying to take, remember with the octet rule, they're trying to take an electron away to be complete, to be noble. So that's the halogens. And the alkalis will change the color. We'll use that color, butterscotch color. The alkalis, they react better with, get that with in there, non-metals. So it's hard to compare which one's more reactive. But for the alkalis, the most reactive is francium, way down here. And the most reactive for the halogens is fluorine. Now, there's another word now we have to talk about, electron affinity, that some students get confused. Well, let's talk about electron affinity now. All right, now here we have electron affinity, and it increases as you go up with the alkalis, and it increases as you move to the right. And the one with the most electron affinity, this is where it gets confusing for some, make sure we'll use blue, is chlorine. It has a higher electron affinity than fluorine. So what does that even mean? Well, electron affinity, and I'll write it over here, is the amount of energy that's liberated, freed, released, right, when an electron is added. So if you add an electron to chlorine, there'll be a stronger bond, a much stronger bond than with fluorine. So there'll be more energy liberated in chlorine than fluorine. Even though fluorine will attract electrons more, they'll feel a little repulsion because of their, let me get a picture to show you, because of their nucleus, because of their orbits. I'll show you a picture. So again, just remember this definition, the amount of energy liberated when an electron is added. Okay, and let's look at the two Bohr models of them. All right, and so we have fluorine on the left, we have chlorine on the right, and you can see fluorine is much more compact. It has two rings, it has two shells. Let's use blue, get our blue ready. So it has, you could say two orbits if you want, two shells, two clouds. So it's more compact, and chlorine has three orbits, or rings, or shells. So it's more spacer. And because of that, if an electron joins, and by the way, they both want one more. They're both trying to fill that octet rule. So when an electron joins here, it's going to feel more repulsion, because they're all negative. They're negative charges, and like charges want to be repulsed. They want to stay away from each other. So it's going to feel more of a repulsion. than the electron visiting the chlorine. And because that, chlorine will have more energy involved. So you can think of it, you're coming to a new school and it's a smaller school. So if no one likes you in that school, you'll feel it a lot more than if you did it in a bigger school. Well, maybe that's a poor analogy. So basically, again, fluorine is more compact. So the electron coming in is going to feel more of a repulsion than it would with the chlorine. And that's why chlorine has a higher electron affinity. Again, the electron affinity is the amount of energy released when an electron is added. So again, fluorine will attract electrons more than chlorine because it has a high electron negativity. But once that electron comes in, because it's more compact, the electron feels more of a repulsion. So it's not as stable. So the chlorine atom will have stronger bonds. And again, just to review, remember we talked about electron negativity, electron positivity. Both of them will indicate a strong reaction. And again, going to the periodic table, let's look, right? The alkalis on the left, the soft metals on the first group over here, they're electropositive, very reactive. And like I said before, francium is the most reactive of the alkalis. And then the halogens over here, fluorine is the most reactive, but chlorine has the highest electron affinity. And we talked about the nobles, they're inert. Spell that right? Let's spell that right. They are inert. Now, I did mention that krypton can react with fluorine and oxygen at cold temperatures. So there is some exclusions to that rule. All right, that's our lesson today.